Hi everybody, this is obviously the second day from section 4.6 and we are still talking about solving equations by completing the square and rewriting functions by completing the square. Those were our two objectives that we're going to be working on today. And we need to realize that the method comes from the fact that there are a lot of polynomials out there that cannot be factored, and that's just real life. Real life is messy numbers, so we have to work more towards that solving quadratics by methods that are not factoring. And our getting ready here has an interesting visual to help us figure out what are we doing when we're completing the square. So how can you use pieces like these to form a square with side length of x plus 3? And no overlapping pieces. Show a sketch of your solution and how many of each piece do you need, and explain. And under the little avatar drawing here, you see this suggests another way to write the quantity x plus 3 squared. And sometimes this really helps students to figure out what on earth are we doing when we're completing the square, because there's an actual square involved in this picture. So if x squared plus bx is not part of a perfect square trinomial, and remember, we have our standard form ax squared plus bx plus c. So ax squared plus bx is not part of a perfect square trinomial. You can use the coefficient b, so our middle number there that's right in front of the x term, to find some constant for c so that it will be a perfect square. When you do this, you are completing the square. We are making a square, and the diagram models this process. So let's take a look at this. It says, all right, if you're supposed to do x squared plus bx, well, here, you know this is a rectangle. This isn't a square because this is only x. This is x, but you have this additional little b on there. So what do? Well, one thing that would help would be if you cut this in half and slid that piece over here. And that's what we see in the next drawing. So they took b and they sliced it in half, and that gave them 1/2 b, which is b over 2. But it's still not a square. You're still missing this right here. But through an educated cheat, you could say, well, I know what has to go there, because this side length is b over 2 and this side length is b over 2. So it's going to have to be b over 2 squared to make that work. So this is the part right here where we say, all right, got to take the middle term, divide it by 2, and then square it. And then we will have completed the square. For some reason, blue just doesn't want to work. There we go. We will have completed the square. So we are trying to make that perfect square trinomial that will make this work. And b over 2, the quantity squared, remember that's not something that you would have to memorize. Let me give you an example here. When we factored x squared plus 6x plus 9, we said this is x squared and this is 3 squared. And if we multiply those together and we double it, then we'll get a 6. But we're doing this process backwards. So we're going to start with b. For whatever reason, the blue is just having a hissy fit here today. We're going to start with b, and we're going to do the opposite of what we had to do, which would mean we're going to have to divide it by 2. And then, instead of taking the square root to figure out what it was that was squared, we square it. We do the opposite. And 6 divided by 2 is 3, and 3 squared is 9, which is the number that we need over here to complete that square. So again, you can either use this visual with the square to think your way through it, or just reason backwards from what we did when we were factoring. So key concept box here says solving an equation by completing the square. We want to rewrite the equation in the form x squared plus bx equals c. So we're going to move the number that's not a perfect square over to the other side so we can actually get a perfect square. To do this, get all terms with the variable on one side, so anything with an x on one side of the equation. and put the constant, just the number, on the other side. Then, this is really important and they don't make a big deal out of it here. Divide all the terms of the equation by the coefficient of x squared if it is not 1. To complete the square, it must be 1x squared plus bx plus c. If there's anything else in front of that x squared, we have to divide it out. Now, once we have that out of there, we're going to complete the square by adding b over 2 squared to each side of the equation. We're going to factor our perfect square trinomial. That'll give us a binomial squared. And once we have something squared, we'll find the square roots and we'll solve for x. So, just to get back into completing the square from yesterday, this says let's solve this by completing the square. Step 1, move the constant over. Because pretty obviously, negative 15 is not a perfect square. We've been talking about that list of perfect square for a couple of days now, and that is definitely not on it. It can't be negative. Perfect squares can't be negative. So we're going to add 15 to both sides. And then we have to figure out, well, what number would it be that I have to have for a perfect square for that left-hand side? And I realize, well, 8 is my b value. And my little formula is b over 2 squared. So it will be 8 divided by 2 squared, which is 4 squared, which is 16. So I have to add 16 to both sides. Now, the right-hand side, we can add 15 and 16 together. That's 31. The left-hand side, we already know it needs to go there too, because we know that we have to get a binomial squared, and x squared will give you x squared. And then we realize, well, I know what I have to square to get 16 too. I just wrote it down over here. It's 4. That's what I have to square. And then you can just check between your first and second term to see whether or not it should be a plus or a minus. And this one has a plus for the middle terms, so that's going to need to be a plus. Now, we have a squared. I'm going to write another step here so that people can see that the next thing that we do is take the square root of both sides. And that will give me x plus 4. Rewrite that. It's a little crisper right there. X plus 4 equals plus or minus the square root of 31. We talked about that, about how whenever you physically write a square root symbol, you have to put the little plus or minus piece in there. And then we'd think, okay, square root of 31. Do I have any perfect squares that would go into 31? We try 25, we try 16, we try 9, we try 4. No. So that's already simplified. And the last thing we have to do is subtract the 4 from both sides. So x equals negative 4 plus or minus the square root of 31. Now, we could keep going with a calculator. I mean, we could figure out what negative 4 plus the square root of 31 is and write it as a decimal, what negative 4 minus the square root of 31 is and write it down as a decimal. But completing the square is about getting perfect answers, and perfect answers are messy. The square root of 31 is definitely messy. We have two answers here. Negative 4 plus the square root of 31 and negative 4 minus the square root of 31. And they are two beautiful little answers that are perfect. Another example to try here, this one. Maybe you go ahead and hit pause and try on your own and then watch me complete it. So first things first, negative 21 is not a perfect square. Going to need to move it over to the other side. Then what we need to do is figure out, well, what is going to work? So whatever we do to one side, we have to do to the other. And I realize that my b value is negative 4. And I need b over 2 squared. So negative 4 divided by 2 is negative 2. And negative 2 times negative 2 is 4. Remember, use parentheses if you're going to use a calculator for that. Otherwise, the calculator will tell you that's -4, and we know it's not. -2 times -2 is +4. You always get a perfect C value. It's going to end up being something that's positive because 2 negatives multiply to a positive and 2 positives multiply to a positive. Now, we have a very lovely little 25 on one side, and on the other side we know that we had x that had to be squared, and we look back here and realize, oh, look at that, we even had the negative on there. That's going to be an x minus 2 because between the first and second term we see subtraction. Then take the square root of both sides. X minus 2 equals plus or minus the square root of 25. Have your light bulb moment where you go, oh, square root of 25, that's 5. And then we'll add 2 to both sides. Now with this one, we're not done because those are both integers. We can do that addition. We know what the answers will be if we do that addition. We know that 2 plus 5 equals 7. And we know that 2 minus 5 equals -3. So our answers are x equals 7 and x equals -3. There they are. So completing the square, it is a way to understand, not just use, understand what's happening when we're solving a quadratic by making a perfect square. And that's because we have all that experience with factoring. That's why we had to do so much factoring, so that we were just experts at it and knew what to look for. So this one says we're going to do solving by completing the square. Obviously, that's what this section and our objective is about. And what is the solution of 3x squared minus 12x plus 6 equals 0? So I start to think, ooh, this looks different. This must be a new chunk of information here. And I realize, oh, there's a 3 in front of that x squared. That has to be a 1. So these first 2 steps that we see here in the blue, they are interchangeable. And most students prefer moving the 6 over first and then dividing by the 3. The danger there is that you'll forget to divide by a 3. So if you know you're not going to forget to divide by the 3, then it's perfectly fine to subtract 6 first and then divide by 3. And when we say divide by 3, we mean everything. Now with this one, it's not going to make it less or more complicated to divide by the 3 to start with. The reason I say that is sometimes when you divide by the number that's in front of x squared, the a term, you end up with fractions. But with this one, it's not going to make any difference. So these 2 steps, like I said, as long as you remember to divide, they're interchangeable. Then we calculate b over 2 squared, the number that we need right here. So -4 is b divided by 2 is -2 squared, which is 4. So we have to add 4 to both sides. On the right hand side, -2 plus 4 is 2. And on the left hand side, we have our perfect square trinomial. We know that x times x would give us x squared. And we also know that we just got done squaring -2 for that piece. Then we'd take the square root of both sides, and we'd remember to put plus or minus the square root of 2. And we realize square root of 2, there's nothing we can do with that. It's just going to have to stay that way with that radical, and that's called irrational. So it has to stay irrational. And then we'll add 2 to both sides. So there are our 2 solutions. X equals 2 plus the square root of 2, and x equals 2 minus the square root of 2. So the information that this problem had is a new chunk where we have a value for a in the front that's not 1. And that's important. That, again, in real life, happens a lot. So we have to know, how do we complete the square when things don't work out perfect? So here's the got it, and this would be a good one for you to pause the video, try it on your own, and then start it back up. First thing for most students is going to be, we need a 0 on one side. If we're going to solve, let's take a look at what we're doing first. So let's subtract an x and a 9 from both sides, because we always want to keep that squared term positive, if at all possible. And that gives me 2x squared minus 2x minus 6 equals 0. And now again, those first two steps that we take are interchangeable. So let's just say you decide you're going to divide by 2 because you're worried that you're going to forget if you don't do it now. And this would give us x squared minus x minus 3 equals 0. So this one, again, worked out nice and didn't give us any fractions when we divided by the 2. Now, next step would be, oh, well, that negative 3 is definitely not a perfect square. I better move that over to the other side by adding it. And now I need my little b over 2 squared. Now, a lot of times when we've done b over 2, it's worked out really, really nice. It's come out to be a nice integer. With this one, our b value is negative 1. And remember what we talked about when we were simplifying square roots, that the place that that power is in is really important, because that's telling us the exponent works the closest thing to its left with it, which is parentheses. So if you don't want to use a calculator, you could write it out as negative 1/2 times negative 1/2. And then to multiply fractions, you multiply top times top and bottom times bottom. So plus 1/4. Or you could do that whole process on your calculator. So you could say, I need negative 1, parentheses, negative 1 divided by 2, parentheses, squared, and then math, number 1, fraction conversion, enter. And there it is, perfect little 1/4. So don't fret the fractions. Graphing calculator will do those. Now, you need to know what 3 plus 1/4 is. I'm going to do that by hand, but if you didn't want to, you could put it in the calculator. 3 plus, parentheses, 1 divided by 4, and then math, fraction number 1. 3 is the same thing as 12/4 with a common denominator, because this would be a little 1, so you'd multiply the top and the bottom by 4 to get a common denominator of 4. You write that up here, maybe in a different color. And that's going to give us 13/4. On the other side, we now have a perfect square trinomial. So definitely we square x to get the x squared piece, but the question is, well, what did we square to get that 1/4? Well, we already know. That's back over here when we did b over 2 squared. That was minus 1/2. So now, the next step would be to take the square root. X minus 1/2 equals plus or minus the square root of 13 over the square root of 4. Now I did that for what I hope is an obvious reason. I hope you can see, oh, the square root of 4, that's 2. Let me write that a little bit better. I wrote that really fast, and the smartboard didn't catch it. So I'm going to have x minus 1/2 plus or minus, and the square root of 13 equals plus or minus. The square root of 13 is prime. Only 13 and 1 divide into 13. So we're not going to be able to do any simplifying there. But no big deal. That's in the numerator. Nobody cares if it's in the numerator. We really care if it's in the denominator. And then last but not least, we will have to add 1/2 to both sides. So x equals 1/2 plus or minus the square root of 13 over 2. And those are our two answers. 1/2 plus the square root of 13 over 2, and 1/2 minus the square root of 13 over 2. And you can write them separate, or you can leave them just like that. And I will know that you have your both answers right there. Alrighty, this is a really good review problem, but I'm going to stop and darken that graph. Alright, so that's much better, even though there's still looks like it's not quite fully on there. So this one says, let's graph y equals the quantity x plus 2 squared plus 1. Now, why on earth is that in here? We've been doing completing the square. Well, look at it. It fits perfect. That's a binomial squared. So this was vertex form. And the reason we really liked vertex form when we were graphing is because it was really nice and simple and it went really fast. So here's what we learned about vertex form. We're going to graph y equals a x squared. We'll just make a table of it. And the a value in this one is 3. But we don't have to do a lot of numbers. We really just have to see what's going on 0 on the positive side. So maybe 0, 1, and 2. And whoops, and I need to write those in the x, not the y. There we go. And we'll square it and multiply by 3. 0 squared is 0. 0 times 3 is 0. 1 squared is 1, and 1 times 3 is 3. 2 squared is 4, and 4 times 3 is 12. So that's going to take us a little off our grid. But we've got 0, 0, 1, 3, and 2, 12 up there. And I know that it's symmetric with the y-axis because we don't have an h and k yet. So I want to put those on there. And then dashed or dotted, kind of a skinny little thing it should be because we had a 3 in the front of it. And then all we have to do is move it. So we have to know what the translation is. And we have to remember that x is naughty. It always does the opposite of what we think it should do. So translate 2 units to the left and k in the back, totally normal. Up 1. So what I need to do is move my 0, 0 to its new vertex point, which will be at negative 2, 1. But to do that, I'm going to go ahead and just move those really nice points I had on the right side of the graph. So 0, 0 is going 2 to the left and up 1. And 1, 3 is going to go 2 to the left and up 1. And 2, 12 is going to go 2 to the left and up 1. And now I want my new axis of symmetry. Which of course is x equals negative 2 because it always goes through the x coordinate of the vertex. Then use symmetry to go equal but opposite on the other side. It's having trouble with the blue again. Does not like the blue today. Fine. Then I won't use blue. I'll use the black. Trying to get past all the shadows here. Seem to be really bad in the afternoons when I videotape this. So there it is, 2 units to the left and 1 unit up. Now, that doesn't take a long time to do that graphing. That's why we really like them in vertex form. And after a while, the other thing that we'd want this for is we tend to forget that little formula negative b over 2a for finding the x coordinate of the vertex. So this is building us to the next chunk, which would be our other part of our objective. And that one was rewrite functions by completing the square. So what we want to do is take a problem that's in standard form and make it be vertex form. So writing in vertex form, it says you can complete a square to change a quadratic function to vertex form to make it look like this. To which I hope you're saying, of course we can. We just learned how to complete the square. So what is y equals x squared plus 4x minus 6 in vertex form? And then name the vertex and the y-intercept. Well, once we have it in vertex form, that's going to be a piece of cake. All right, first things first. Negative 6 is not a perfect square. So we have to move it over to the other side. But notice, that's not a 0 on the other side, that's a y. So don't lose it. Y plus 6 equals x squared plus 4x. That y has to come along with us. Then we need to complete the square on the right-hand side. And that takes our little formula b over 2 squared So 4 divided by 2 squared, which is 2 squared, which is 4. Now on the left-hand side, you should be saying to yourself, I know what 6 plus 4 is, that's 10. Y plus 10, remember, don't lose the Y, equals something squared. We just made this a perfect square trinomial by completing the square. And then we remember, oh yeah, x goes in here, and what did I square to get that 4 again? I squared 2. Now, we are not solving. That's really important. We want this in vertex form. We're going to have it in vertex form when y is all by itself. The only thing that we have to do to get y by itself is subtract 10 from both sides. And no, we can't put that in there with that 2 because that 10 doesn't have anything squared. The powers don't match, so we can't do anything. We just leave it like that, which makes more sense anyway because we wanted it in vertex form. So now we are supposed to answer the questions about where the vertex is and where the y-intercept is. So go ahead and write down the vertex and write down the y-intercept, if you remember how to do those. The vertex will be at -2, -10. Again, x is the opposite of what it appears to be, so it says x plus 2. It's actually a -2 that went in there, and then -10 from the back. Now the y-intercept, that was kind of a trick question they threw in here, and that's because the y-intercept is actually easier to find in standard form. So we need to go back to the original, because way back when we studied these in section 4.1, they told us the y-intercept will always be 0, c. Well, here's c, -6. So while vertex form is easier to get the vertex, well, standard form is easier to get the y-intercept. So there's a use for both forms. But if we're graphing, yeah, vertex form is going to be our choice. It absolutely is. So number 6, hit pause, give this one a try on your own, and then start it back up. Well, the 6 is not working. It is not a perfect square. And it's a -6, so we add it to both sides. Then we have to complete the square. So this one has a b value of 3. And again, if you want to do it by hand, remember that means we have to take 3/2 times 3/2. Top times top is 9, bottom times bottom is 4. So we're going to have to add 9/4 to both sides. Now, it's up to you whether or not you want to do common denominator or if you want to grab your calculator, but make sure that you give me back an improper fraction when you do this. So, off to the side here, let me show you what we need to do. We have 6 over 1. We need to add that to 9/4. Well, that means this is going to need a 4 on the top and the bottom to make that happen. They need a common denominator. So 24/4 plus 9/4 would give us 33/4. So we have really done some work there with the fraction to get that 33/4 piece. All right, on the other side, this is easier because we know what we just squared. We just had to square 3/2. But now, don't try and solve. Don't take the square root. This is where we say, okay, now I need to move everything but the y back over. So we're going to have to subtract 33/4 from both sides. Y equals the quantity x plus 3/2 squared minus 33/4. So that one had some fun fractions in there. And now we answer the question, which was about finding this in vertex form, which we did. And now we want to tell them the vertex. So that will be -3/2, -33/4, because x is always the opposite of what we see up there. And then for the y-intercept, we want to go back to the standard form and say, okay, A, B, C. Ooh, -6 again. 0, -6, just like in the last example that we had, just above this one. So that actually, these last two especially, meets what our objective was for the second half, which would be rewrite functions by completing the square. And that puts them in vertex form. So now not only did we solve equations by completing the square yesterday and today, but we have also taken standard form equations and made them into vertex form by completing the square. And it's a totally understandable process because of what we know about taking a binomial and squaring it. Most people do just memorize the b over 2 squared piece, but remember, you can always think backwards to what we know about foiling those two together and what we know about factoring a perfect square trinomial and using that process backwards. So for section 4.6 day 2, page 237, do 29 to 43, just the odds, and then 46 to 51 and 63 to 66. And have a good weekend.